Hi guys, in this video we are going to take a look at how we solve equations when we have variables on both sides of the equal sign. So just for an example, if you look at number 1, here's our equal sign, and notice that in this one we have c's on both sides of that. We haven't run into that before. This is the first time where we're seeing a situation where there are variables on two different sides of that equal sign. So I'm going to walk you through how to do this. The instructions are going to be, we're solving each problem by showing work on both sides, so we're solving it algebraically, and then we want to check our solution. And this time we really are going to show a check physically because it's a different type of equation, and we really want to make sure that we're getting these answers correct. So we're going to do a few of these together, and I'm going to leave a few of them for you to do on your own, and then we'll have a checkpoint just to make sure that you can do these completely, and I'll check you for accuracy on that. So this guy, negative 7c plus 9 equals c plus 1. So the first thing that we want to look at is we're looking at each side of the equal sign just to ask ourselves, is there any way that we can simplify? So just looking at that left-hand side, is there any simplifying we can do? Any combining like terms or distributive property? No, it's just a c and a constant. We can't add those together. What about over here? Just a c and a constant. We can't add those together. We can't do anything with them. Are we allowed to combine these c's and this c right here? Negative 7c plus c? No, we can't, because there's not a plus in between them. That's an equal sign in between them, so they're on completely different sides. You cannot combine them together if they're on different sides of the equal sign. So we're kind of stuck in our normal ways of looking at this. We're ready, if we can't simplify, to try and solve, which always means get the c by itself, or the variable by itself. But in this case, it's in two places. It's going to be hard to get it by itself if it's on both sides of the equal sign. So our task is get rid of it in one place. We either want to get rid of these negative 7c's or get rid of this c that's right over here and put them all on one side together so that we can just have a c by itself that we're getting rid of. So the question is, which one do we want to get rid of? And the answer is, it doesn't matter. We could get rid of the negative 7c's, we could get rid of the c's. As long as we're doing it algebraically, we're going to get the same answer at the end. So when we think about getting rid of these, how would I get rid of negative 7c's that were sitting there? I want all those c's to go away. So if there's like negative 7c's sitting on a table somehow, and I'd want to make them go away, I'd need to bring them up to 0. Right? So how would I bring negative 7c up to 0? Well, I'd add 7c. Isn't negative 7c plus 7c? Combine those like terms, wouldn't you get 0? So if I do that, it would make this go away. And then I can do it as long as I also do that to the other side. Whatever I do to one side, I have to do to the other. So to get rid of negative 7c, I added 7c. And let's bring down what's left. Over here on the left, all that remains is a 9. We still have our equal sign. But now over here, I have c plus 7c. So there's only one c there. 1 plus 7 is, now I have 8 c's, and I still have this plus 1 hanging out there. So just with that move of doing something on both sides with the c's, now all of a sudden, they're all in one place. And this just looks like a regular old two-step equation that we've done so many of. So now it's this c that I want to get by itself. What's in the way of the c's being by themselves? This plus 1, that's got to go. Bye-bye. And 9 minus 1 is 8 equals 8 c's. At this point, still need to get that c all by itself. So to get rid of 8 times, I divide by 8, and I get 1 equals c. Right. So in looking at that, if I go back to my first step right here, I decided to get rid of the negative 7c's. I could have decided to get rid of just the 1c. What would I have chosen to do if I wanted to just get rid of 1c? How would I get rid of this 1c? I would subtract it away. So I could have, in my first step, done minus 1c on both sides. And this next step then would have looked a little bit different, but in the end, I still would have gotten, through a little bit different steps, that c equaled 1. So it doesn't matter which variable you choose to get rid of, as long as you get rid of the variables on one side of the equation. So we are, like I said, going to plug in this answer to see if it works. And this check looks a little bit different because we've got variables on both sides. So I'm going to ask you guys to either do it right here, or if you don't have enough room, you could always do it on another piece of paper. Or if you've got room, you could do it underneath here. But we are going to do a check, and we're going to plug in 1 every time there's a C. So I'm going to rewrite this equation exactly as it was, except every time there was a C, I'm going to try 1 and see if it ends up being true. So we start off with -7, and it was -7 times C. So -7 times 1 plus 9 equals, and I'm still writing it exactly the way it was, C, which is 1 plus 1. So I get this equation right here, which I'm going to put a question mark at the end because I want to see if that is true. And the only thing that's different about this is there are things to simplify on each side right here. In the past, when we checked it, we always just had equals 10 or equals 50, something on one side. Well, now we do have some simplifying on both sides to do. So what is -7 times 1? Well, that's just -7, still plus 9. What is 1 plus 1 over here? 2. Does -7 plus 9 equal 2? Yeah, because -7 plus 9 is 2. So we get all the way to, yes, it is a true statement, so that true statement means that C equals 1 is a correct solution. So I am going to ask you to actually show the work for the check and to simplify each side until you can prove that it is equal to each other on both sides. All right, I'm going to save number 2 for you to do. Let's try number 3, because number 3, if we look at it, there is some simplifying that we can do on one of the sides before we start to solve this. We've got, on the left side, no simplifying. There's no like terms or distributive property. But on the right side, 7 parentheses x plus 3. So there is a distributive property that I can absolutely do before I'm ready to solve this. So 7x plus 7 times 3 is 21. So all I did was simplify that side. I am going to bring down everything that was on this side, so I'm looking at the whole equation together now. All right, no combining like terms here, no combining like terms here. Can I add 3x plus 7x? No, there's no adding sign in between them. There's an equal sign. We can't combine those. So now my question is, I've got x's over here and x's over here. I need to get rid of some of them. Some of them have to go. So you can choose which ones you need to get rid of or you want to get rid of. Either way will work. I'm going to choose the 3x. So to get rid of 3 x's sitting there, I need to take them all away. 3x minus 3x will turn that into 0. 3x minus 3x, bye-bye. Whatever I do on one side, I also have to do to the other. And now we'll bring down what's left. In this case, 7x's minus 3x's leave us 4x's, and there's still that plus 21 hanging out. So there's our new equation. There's our two-step equation, and we've done many like this. Now we just need that x by itself. So what's in the way of the x by itself? The plus 21. So we subtract 21 from each side. And then 5 minus 21 is going to give us, what, -16? Equals, this went bye-bye, that was the whole purpose, equals 4x. And now to get that final x by itself, we just need to divide both sides by 4. And just be careful, a negative divided by a positive is going to leave us with a negative -4 for a solution. Okay, we are going to check that, and we are going to make 100% sure that we are right with this solution. So we're going to go back, and I'll do it right up here. Rewrite this original equation. Now this is really important, guys. You need to go back to the original. We don't want to plug it into, say, this first step right here, because if we had made a mistake somehow in the distributive property, and we plug our answer into this first step where there was already a mistake, it will not catch that it's the wrong answer. So we need to go back to the original, always to what we started with. And what we started with was 5 plus 3 times x. So 5 plus 3 times -4 equals 7 parentheses, and I'm going to go into my workspace over here for number 4. So maybe I'll do number 4 on a separate sheet. That's okay. 7 parentheses -4 plus 3. All I did was plug in my x for my 4. And now, here's my equal sign, I'm just going to go and simplify each side and see if I get to the same number at the end. So let's try and work on each side. I have to multiply before I can add. I can't just add 5 plus 3. So 3 times negative 4 is negative 12, and then there's a 5 plus in front of that. Now over here, guys, I don't have to do the distributive property here because there's no variables. I can just add what's in the parentheses first. What is negative 4 plus 3? That's going to be negative 1. And then there's still a 7 outside those parentheses. All right, now I'm going to simplify each step one more time here. What is 5 plus negative 12? Negative 7. Over here, what's 7 times negative 1? Negative 7. Does negative 7 equal negative 7? Sweet. All right, we've checked it. We've made sure that x equals negative 4 is our solution that we want. All right, so let's do one more together. You might as well do 5 since we're kind of doing this column right here. Let's go down to look at 5. Let's see if we can figure out what to do here. Is there anything that we can simplify on there first? Distributive property or combining like terms? No, and we can't combine the m's yet because they're on two different sides of the equal sign. I can't just add them together. But looking at this, there are still m's on both sides. So my new thing today is I've just got to get rid of some of those m's. So I need to decide which ones need to go. Now, this time, I'm looking at this. And if I got rid of those 12 m's, I'm going to be subtracting 12 m's from both sides. And that's going to give me a negative number of m's over here. I totally could do it. There's nothing wrong with it. But in my mind, I'm thinking, well, if I try to get rid of the 4 m's and subtract 4 m's from each side, I'm still going to have a positive number over here. I'd rather have negative numbers than positive numbers. Sorry, I'd rather have positive numbers than negative numbers if I can help it, just because I might make fewer mistakes on negative signs. So this time, oops, sorry guys, I'm going to subtract these 4 m's over here. 4m minus 4m is going to take it down to 0 m's. That's what I wanted. I didn't want any m's on that side. But whatever I do to one side, I need to do to the other. So let's see what we have remaining over here. 12m minus 4m is 8m's. And I still have this minus 9. Bring down my equal sign. And everything that's gone over here except for the 15. So there's my two-step equation now. So now I just ask myself, what do I need to do to get the m by itself, since it's only in one place right here? I need to get rid of that minus 9. So I am going to add 9 to both sides. Goes away. And we bring down what's left. 8m equals, and we've got 15 plus 9, which is going to give us 24. Divide both sides by 8 to get rid of the 8 times. And we get m equals 3. So we think that m equals 3. We're going to do a quick check where we physically plug it back into the original equation and just see. I've got some room at the bottom of my paper this time, so I'm going to do it down here. My check. Write this exact original equation, except instead of the m's, I'm putting in 3's. So that says 12m, which means 12 times m. So I'm going to write 12 times 3 minus 9 equals, and then instead of 4 times m, 4 times 3 plus 15. And our question is that true? Does this side equal this side? Is 3 the correct solution? So let's just start simplifying each side. Over here I can do some multiplication. 12 times 3 is 36, and we've still got a minus 9. Let me see if I can do a step of simplifying over here. 12 times 3 is, 4 times 3 is 12 over here, and we've still got a plus 15. And then let's simplify this side. 36 minus 9 is going to give us 27, and 12 plus 15 is going to give us 27. Woohoo! So that's correct. Now guys, what would have happened if we got something like 24 equals 27 when we did this? Well, we know that that wasn't the correct solution because it didn't give us the correct two numbers that were equal to each other. So if we got 24 equals 27, we'd have to go back and go step by step and try and find a mistake in our solving process and see how we had come up with the incorrect number. Maybe redo the problem on a separate piece of paper to start over and see if we could catch it. Usually what happens is we have mistakes with negatives along the way somewhere, so you will probably get to one at some point that when you check it, it doesn't work, and you say, oh boy, I need to go back and see what I did wrong, see if I can redo that one to get the correct solution. All right, so your job right now is to do 2, 4, 6, and then you'll be ready to do checkpoint number 2, which we will look at and check for accuracy. So when you're done with 2, 4, and 6, go ahead and show the teacher so that you can move on to the next step. All right, guys, we'll see you later.